some intergalactic object that's hurt. There's this guy, Avi Loeb. He's a professor at Harvard that believes it might be an alien probe.
3I Atlas is hurtling sunward along a hyperbolic trajectory, plunging into the inner solar system with a sense of cosmic inevitability. Its path will take it closest to the Sun on October 29, 2025, at about 1.36 astronomical units, a distance that places it between the orbits of Earth and Mars. That journey, however, conceals not only an astonishing celestial spectacle, but also a series of scientific revelations, with the power to reshape our ideas about comets, planetary systems, and the nature of interstellar visitors. Before we start, smash the like and subscribe buttons for more updates. When the comet was first cataloged by the Atlas Survey Telescope in Chile on July 1, 2025, astronomers understood immediately that it was unlike anything they'd seen before. Its inbound speed and trajectory made clear that it was not bound to our sun. It came from beyond. In the weeks since, telescopes and observatories around the world and in space have turned their eyes toward it. With each passing day, 3I Atlas sheds fresh clues about its nature, about the kinds of building blocks that roam between the stars, and about our assumptions about cosmic wanderers. One of the most astonishing recent findings is just how early the comet begins to lose volatile compounds, water and other ices, even when it remains far from the sun. Instruments such as the Swift Observatory detected water vapor and hydroxide ions at around 2.9 astronomical units, long before classical comets of the solar system would begin their intense sublimation. That means that thermal processes and volatile behavior in interstellar comets may operate differently, perhaps because of a more fragile internal structure or because of a different mix of ices driven by its history in deep space. The James Webb Space Telescope JWST was next to weigh in, focusing on the infrared signatures of gases around 3Y Atlas. To many scientists' surprise, its coma, the cloud of gas and dust surrounding the nucleus, proved dominated by carbon dioxide CO2 rather than water vapor. The CO2 to H2O ratio, estimated at about 8:1, is among the highest ever observed in a comet at that distance from the Sun. Traces of other gases such as carbon monoxide CO, carbonyl sulfide OCS, even dust and ice also appear. But the dominance of CO2 suggests that 3I Atlas is not only chemically exotic, but possibly formed under different conditions than comets in our own system. A high CO2 fraction may imply that 3I Atlas formed near the CO2 ice line in its home system, or experienced radiation or irradiation that depleted water ice relative to other volatiles. The chemical oddities do not stop there. Spectral observations have revealed the presence of atomic nickel vapor, cyanide gas, and organic compounds. Again, features that echo cometary behavior, but with a twist. Meanwhile, polarimetric observations, studying how light is scattered by the dust in the coma, reveal a striking negative polarization signature unparalleled among known comets or asteroids. At small phase angles, 3I Atlas exhibits deep negative polarization reaching 2.7%, with an inversion angle around 17 degrees. That inversion and polarization curve are more reminiscent of distant icy trans-Neptunian bodies than typical comets. All of this suggests that the dust grains, size distributions, and surface properties of 3I Atlas may be unusual, perhaps coated in organic layers or formed under different thermal histories. Adding to the mystery is the pattern of its brightness history. Pre-covery images by TESS, stretching back to May-June 2025 when the object was at about 6.4 AU, show that it may have already been active, faint, but shedding gas or dust earlier than expected for typical comets at that distance. That early activity, along with its later brightness and spectral features, together suggest that 3I Atlas may be more sensitive to solar heating than conventional comets, or perhaps contains unusually volatile ices that begin sublimating at lower insolation. That the comet's nucleus is still poorly constrained in size complicates interpretation. The light from the coma and dust obscure what the solid nucleus is doing. Estimates place its diameter somewhere between a few hundred meters to several kilometers, but many scientists favor a smaller size, conditioned by the dominance of gas and dust emissions. Its velocity, combined with highly hyperbolic orbital parameters, confirm that it is not and never was bound to the sun. It is destined to swing past and depart, never to return. As 3I Atlas approaches perihelion near the sun, its activity is expected to intensify. Sublimation will accelerate, dust and gas emissions will ramp up, and outgassing jets may create asymmetries or even cause fragmentation. Scientists expect that the coma and tail will become more pronounced, possibly producing fresh insights into internal structure and surface layering. The sun's heat may reveal interior volatiles that have remained stable since the comet's birth. Changes in emission strengths, morphological shifts, or unexpected outbursts cannot be ruled out. One controversial strand of thought, championed by Harvard's Avi Loeb and collaborators, posits that 3Y Atlas might not be purely natural. Based on its orbit, peculiar alignment, and high outgassing in unexpected regimes, Loeb has allowed for the possibility, as a thought experiment, that it could be a technological artifact or even a probe, rather than a comet in the classical sense. Some propose that it might emit light from the nucleus itself, rather than simply reflecting sunlight, hinting at an internal energy source. Others suggest that it may strategically transit behind the sun to evade detection, launching probes or revealing its true nature once thermal conditions permit. However provocative, these ideas remain speculative and not broadly accepted, given the bulk of observational evidence aligning with a cometary origin. In contrast, NASA scientists emphasize that all currently observed behavior, the coma, dusty tail, volatile outgassing, speed progression, conform with a natural icy body heated by the sun. Tom Statler and other NASA experts have publicly stated that 3Y Atlas shows no evidence of active propulsion, controlled maneuvers, or signals of artificial origin. They argue that invoking alien technology without direct evidence risks overshadowing the real scientific treasure this comet presents. For now, NASA treats it as a window into interstellar chemistry. The broader implications of 3I Atlas's journey lie in what it tells us, or might tell us, about the nature of small bodies in interstellar space, and the chemical environments of planetary systems beyond our own. If this object formed in a distant stellar nursery or system, the composition it carries across the void is a time capsule from another region of the galaxy. Its high CO2 content, combined with suppressed water output, may indicate that comets from other systems can follow very different evolutionary pathways than those we have studied in our own solar neighborhood. This has knock-on effects for theories of planet formation, for volatile delivery to nascent worlds, and for the distribution of organic and prebiotic materials in the galaxy. Moreover, the polarization signature and dust properties suggest that interstellar comets may harbor variants in grain structure, layering, irradiation histories, and organic coatings. If future interstellar objects are found, comparisons to 3Y Atlas might reveal entire taxonomies of exocomets. For Earth-based and orbital observatories, tracking and characterizing such visitors becomes more than a curiosity. It becomes a way to explore the diversity of planetary materials beyond our sun. Another implication pertains to detection strategies and telescope capabilities. Finding and monitoring a fast-moving, dim, volatile losing object such as 3I Atlas required the combined power of survey telescopes, space telescopes like JWST, ultraviolet observatories like SWIFT, and polarimetric instruments ground-based. It underscores how critical it is to coordinate multi-platform observations early and aggressively if we wish to catch interstellar bodies before they vanish. Future comets may enter with less warning, so refining detection pipelines, extending sensitivity in surveys, and planning rapid response observations will become more vital. The notion that 3I Atlas might be a form of extraterrestrial technology carries, if true, vast implications for human civilization, but it remains speculative until supported by firm evidence. The fact that scientists are even discussing that possibility reflects both how anomalous 3I Atlas appears and how open the scientific community is to unanticipated paradigms. Should any anomalous non-gravitational accelerations, directed emissions, or structured signals appear, that would force a radical rethinking of not only comets, but the very framework of contact with alien intelligence. Even without confirming that hypothesis, the very debate highlights the blurred boundary between the known and the unknown in the cosmos. As 3I Atlas slides behind the sun from Earth's vantage point later in 2025, it may become temporarily unobservable. But by December, it is expected to reappear on the far side, resuming its outbound path and giving scientists another chance to confirm the trends in outgassing, composition, and morphology. The real race is against time. Each passing day brings the comet closer to bright sunlight, increasing thermal stresses, sublimation rates, and the chance for structural disruption or fragmentation. Yet in that race lies the excitement. 3. I-Atlas is more than a visitor. It is a messenger. It speaks of distant realms, of the possibilities of diversity in icy bodies and planetary systems, and of the unknown unknowns waiting between the stars. The path it takes toward the sun may be understood as a narrow window, a moment where human ingenuity and celestial motion intersect such that we can read, in its emission lines and dust trails, a story not just of our own solar system, but of interstellar space itself. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on 3 I-Atlas heading for the sun? We want to hear from you. Thank you for watching, and see you next time.